The screen behind me shows a beautiful picture of the International Space Station, but I've come to talk to you about grassroots astronomy, grassroots observation astronomy. I've been interested in astronomy for only about 3 years, and I've been a member of the Nottingham Astronomical Society for a similar period. Now, we know astronomy is essentially the science of stars, planets and the universe, and before I became interested, my perception of astronomy was of a rather mysterious field populated by a relatively small number of professional astronomers and a few amateurs dotted here and there amongst them. Fortunately, scientists such as Professor Brian Cox have started to increase our understanding of the universe by television programs and books, but even so, the better programs, whether they're on Horizon, Sky Night, whatever, tend to rely on interviews with specialists, and grassroots astronomy is only occasionally covered by taking us to locations at the dead of night, usually a field where amateur enthusiasts are using telescopes of all designs and sizes to view the night sky. So my perception 3 years ago is shared by some or many of you here today. How do we break through these boundaries and get involved? You know, how do we start? Hopefully without spending a load of cash on expensive telescopes. And I intend to tell you shortly how I started and hopefully give you inspiration. But before I do, I think it would be very useful if I paint a fairly simple picture of the scale of the universe for you. This is a diagram of our solar system, the sun blazing away merrily on the left there. And we're the third one along. There's Mercury, Venus, Earth, which is the little blue one, Mars, Jupiter, Saturn, Uranus and Neptune. Now the sun, contrary to what a lot of people believe, is a thermonuclear reactor. It's made of gas, hydrogen fusing to helium, and it's got a surface temperature of 5,500 degrees centigrade. The core temperature is about 15 million degrees centigrade. And just starting to scale things, our Earth would fit into the sun about 1 million times. That gives you an idea of the size of the sun. Now the Earth is 93 million miles away from the sun, and that's quite a critical distance for us. It allows life. We're not too hot, we're not too cold. We call it the Goldilocks zone, it's just right. Astronomers call this distance 1 astronomical unit. And it's a very small distance in astronomical terms. You know, if you go to the right-hand side, where you've got Neptune, that's 30 astronomical units away. Now, as you probably know, our solar system is part of an immense collection of stars, gas and dust, which is our own galaxy, which we know as the Milky Way. Now, it's a reasonable question to ask, well, where's the next star to the Earth within the Milky Way? Well, the next star rejoices in the name of Proxima Centauri, and believe it or believe it not, that's 270,000 astronomical units away from us. So we're starting to scale further and further. In other words, 270,000 multiplied by 93 million miles. But even so, in astronomy, that's a relatively small distance. So then we start to use the light year. Now light travels at 186,000 miles per second. Over the space of a year, it travels just short of 6 trillion miles. That's 6 million miles, 6 followed by 12 noughts. A very long way. This next glorious photograph, not quite as good as Terence's, is of part of the Milky Way, which is actually taken in America. And we can't photograph the Milky Way in its entirety because we're in it. But starting to scale things up, the Milky Way is home to 300 billion stars. That's 300,000 million stars. And remember, I've just talked about the light year being 6 trillion miles. Well, the actual width of the Milky Way is 100,000 light years. Now we can't, you know, for the reason I've said, because we're in it, we can't view our galaxy in its entirety, but we can look outside at other galaxies. Now, this isn't taken by the Hubble. This was taken by a member of the Astronomical Society from his home-built observatory down at the back end of his garden. And this is of the Andromeda Galaxy. And it's quite unique in that it's the furthest object that can be seen by the unaided eye on a clear night. With the unaided eye on a clear night, it appears as a small oval misty patch. And it contains 1 trillion stars. It's at least 150,000 light years across, and it's 2.5 million light years away from us. So what we see when we look at this in the night sky, this little oval misty patch, is not how it is now, but how it was 2.5 million years ago. And this is one of the fascinating things about astronomy. We're always looking back in history at the way things were. And even our view of the sun is 8 minutes late. If I could grope a big sort of tea towel in front of the sun in space and then whip it away, you wouldn't see the sun for 8 minutes after I take that away. Because that's the time it takes light to travel 93 million miles from the sun to us. Finally, just to blow your socks off, they're estimated to be at least 100 billion galaxies in the observable universe. So the reason I'm sort of saying this is because there really are no boundaries to the universe, and there's plenty of marvellous objects to look at. I said a short while ago, after bombarding you with all these facts, that I would explain how I got into astronomy. Well, 3 years ago, I attended a stargazing live event. It was run jointly by the BBC and the Nottingham Astronomical Society at College Woods. I went to it on a Saturday night. Guess what, folks? It was cloudy. But members of the Nottingham Astronomical Society were there with all of their telescopes, and I was fortunate enough to get talking to a chap who gave me some very invaluable advice, and the next slide encapsulates this advice, and I pass this advice on to you. We don't rush into buying a telescope. Telescopes, we tend to use them with very high magnification. We look at particular parts of the sky. We've got to know where we're pointing them. I've got a couple of telescopes, but I don't use them all the time. I've got computerized ones, so it helps me to find things that I, perhaps can't see with my own eyes. But they're not easy to use. You've got to sort of walk before you can run. So we start by using our eyes to identify constellations. And these are chance formations of stars in the sky, but they are the road maps. They help us to find our way around the sky. And then we start to download something really useful like Orion. I think it's the most beautiful program, but it's on my computer at home. It's a free program. It can be downloaded to desktop, laptop computers. It's also available as a mobile app. It's the most glorious program. It will show you a real-time view of the night sky as to what you can see. It's a point in time in the north, south, east and west in terms of stars, planets, galaxies, all of these sort of things. It is really good. And the really good thing about it as well is you'll see how the sky changes with time. And you can fast forward it and you can take it back. So if you sat in your study at 5 o'clock thinking, I want to do a bit of stargazing tonight at 9 o'clock, you can fast forward it and you can actually see what's going to be in the sky at 9 o'clock. You can also see what the sky was 2 or 3 days ago. So it's really very, very useful. So we start stargazing by using binoculars. 10 by 50s are the classic configuration. What we mean by 10 by 50 is that they've got a magnification of 10, but the actual objective lenses are 50 millimeters in diameter. Got clear here, nothing magical. Surely you've all seen binoculars before. I use these all the time. So magnification of 10, the actual diameter of the objective lenses are 50 millimeters. You can mount them on a tripod to reduce shaking of the image. You can take them anywhere. They enable us to view things with both eyes, which is always a plus. With a telescope, we tend to be using one eye into the eyepiece. Now, the reason that they work so well is it's all about light grasp. 10 by 50 binoculars give me something like 100 times the light grasp of objects in the sky that my actual pupils of my eyes can achieve. 100 times. I haven't got time to go into the maths, but it's very, very straightforward. And it's not all about magnifying what we can see in the sky with our unaided eyes. Astronomy is part of discovering what we can't see. And when you first use binoculars, I assure you, if you take them out onto a clear night sky, 10 by 50s, and you start to look around, you will be amazed at what you see. One of the most glorious things I've ever seen, I had those on the tripod once, and I looked at the moon, and it was a particularly nice night, and it remains in my memory, this particular vision image of the moon at 10 magnification through those binoculars. In the night sky, if we went out tonight, say 7:30, 8 o'clock, assuming it's clear. Well, first of all, you don't necessarily need binoculars for this, but this particular constellation over here is in the east tonight, and it's the Cloud. It's an important constellation, an important reference constellation for astronomers. And the reason why is basically because that bottom star there always points to Polaris. And Polaris remains virtually above the North Pole, so that remains in the north. So basically, if you can't be bothered with using a compass to find your way around, once you've actually isolated where the Cloud is, you know where Polaris is, that's in the north, and so by default we can find out where the other points have become star for us. If we go to the southeast tonight, we will see Jupiter, but what we will see with these binoculars is its 4 largest moons. So they get these glorious little jewel-type dots around Jupiter, and this is sort of, similar to these only 2 that you can see, perhaps 3, both of them there, but this is the sort of thing you see through binoculars. And the interesting thing about this particular planet is as the days go by, and these moons are actually orbiting around the planet, you will actually see them moving, in different sorts of areas around the planet. So they change where they are around the planet as the days go by. If we go to the southwest, we've got the constellation of Orion, characterised by the 3 diagonal central stars there. And this is always marvellous to look in and around with binoculars and with just the naked eye. Top left, that orange star is Betelgeuse. That's at least 400 light years away from us. And if you were to imagine the Earth going around the Sun 93 million miles away from the Sun, that circle around the Sun, that particular star is big enough to fit into that circle. So it's a real monster. The bottom right is Rigel. And Rigel is a really bright star that's 770 light years away from us. And it's a good job it is, because it's 50,000 times brighter than our own Sun. It's a real cosmic searchlight. In the middle there, just below the 3 diagonal stars, if you drop down with binoculars, you come to a beautiful glowing misty patch with some central stars in it. And that's actually the Orion Nebula. That's a big area of gas, and it's a star factory. Perhaps you've seen pictures from the Hubble of the pillars of creation, where there's all these pillars of gas with stars in it. That is a star factory, and it is beautiful to look at through binoculars. Beyond this particular picture to the bottom left, we can't see it on there, is Sirius, which is the brightest star in the night sky, and that's 9 light years away. We go above right from Orion, we come to the open cluster of the Pleiades, or the 7 Sisters. Look at it with just really naked eye at night, you might just see a smattering of something, not much at all. Get binoculars on them, the sky comes alive. We're very lucky at the moment, because lower in the west, you'll see Venus and Mars both together in the west. You'll see both of those through binoculars at the moment. And don't forget, when it's up, it isn't up tonight, but when the moon's up, you'll see a lot more detail than you would ever imagine you could see with the human eye. The sea is the craters, the mountain ranges. Just some reference sources, which I've got with me, these particular Philips guides, and they're all fantastic sources of information for you. I can only just say finally, I hope my talk has helped to break down some boundaries for you. And remember, it's easy to enjoy the night sky. It's a free show. It's not like paying to go to Rock City. It's there all the time. And there are no boundaries to it. And also, don't forget the partial solar eclipse next Friday morning. But don't, for goodness sake, use binoculars to view that. Thank you very much for your time.